Hi, my name's Tom Keeling. This is the summary of my recently completed master's degree about gas safety on boats. There I am, and there's my web address where you can find out a little bit more about me and get in touch if you want to. I'm a marine surveyor, boat safety scheme examiner, I'm gas safe registered for boats, and I'm a member of IMREST. In 2021-2023, I've completed an MSc which focused on LPG as domestic fuel on inland waterways boats. The aim was to improve boater safety by reviewing key elements of gas safety and throughout linking design, commissioning and maintenance together as crucial factors to system success. So why look at LPG on boats? Well, it's in widespread use with 76% of boats believed to have gas systems. The sector is undergoing demographic change and it's estimated the liveaboard population grew from 15% in 2011 to 27% in 2020, and the truth is it's probably bigger than that. We have areas of intense concentration of liveaboard boaters. For example, there's an estimated 5,000 liveaboards in London alone, and they're mainly off-grid and using LPG daily, and again, that figure is some years old now. And we have no specific research into gas safety on boats and very little research on the inland waterways in general. So why does it matter? Correct gas system installation, testing and maintenance is crucial to safety. It's not just fire and explosion risk, we've got to consider longer term health considerations such as chronic carbon monoxide exposure and other products of combustion such as formaldehydes. There is academic work out there that shows a link between neurological illness and poor appliance operation, and Professor Bren Croxford is a leader in this field, and there on this slide you can see there are some sources for you to go away and look up should you want to. So I wanted to look at what makes a safe gas system, and if we consider the three key elements to be design, commissioning and maintenance. When we look at design, we need the correct data, we need guidance to apply that data, and in designing the system we need competence. When it comes to commissioning, we need a repeatable, thorough process that tests the design, and we need a process of liability or responsibility where somebody takes responsibility for that gas system prior to it being handed over to a consumer. When we look at maintenance, we need awareness of the requirement for maintenance. There's an element of financial requirement for the maintenance to be completed, and we need the service to be offered for that maintenance to take place. The research method I used had three main focus areas. I did incident data gathering, stakeholder interviews, and experiment and assessment. And throughout I looked at the relevant standards which are listed there for anyone who doesn't yet know. In terms of incident data gathering, the main source I used was the Boat Safety Scheme database, which enabled me to look at the results from 89,000 BSS examinations. I looked at some data from HSE, for example, RIDGAS, and other industry sectors such as caravans. However, there's only limited useful data available for comparative purposes, and that did restrict the contextual analysis. For stakeholder interviews, I interviewed 55 boaters, including some in London to split the diversity. I interviewed 30 registered boat gas engineers and various industry suppliers. Experiment and assessment involved testing of gas systems in theory and in practice to assess the design, and this was unique testing that has not been previously completed on this scale. In some cases, it was the first time a vessel had been assessed by a marine professional. So I carried out theoretical assessment of 59 gas systems with a custom-built installer's mate spreadsheet where I went onto the boat, measured the gas system in terms of length of pipe, amount of joints, kilowatt requirement for the appliances, and then put it into the calculator which told me whether those elements had been designed correctly or not. Following that, I completed practical assessment using a manometer and I was able to check 55 of those 59 systems. So looking at the design elements then, research quite quickly showed that the data for piping size calculations has contained errors in various formats since 2005. Most significantly was ISO 10239 in 2008, and this has been widely replicated from 2008 to the present day in training materials. And when interviewed, 87% of gas engineers used these training materials for piping size data. So the error that came through from that standard that had the pipe size data error in it can be seen in the tables here. On the left hand side is the correct table, which shows you pipe size resistance calculations or measurements for the inside diameter of hose and pipe. And on the right hand side, the table or chart from the training materials, which shows you the same measurements but claims it's for the outside diameter of pipe. It's a very subtle difference, as you can see, but as this slide shows here, the correct table leads you to pick the pipe on the left, and the incorrect table leads you to pick the pipe on the right. So looking here at this example, and you can pause and read through this to please yourself there, but the essence is there in the bold. We're looking for a design drop over a system of equal to or less than 2 millibars. Using the table on the left, the correct one gives us 1.62 for our example. Using the incorrect chart on the right hand side gives us 4.5. So from the start, the designer has built in a problem to that gas system. So why does pipe size matter? It matters for correct appliance operation. It matters because the manufacturer has built that appliance to operate at a designated operating pressure, and we are required by GSIUR and the manufacturer to install that appliance to operate correctly. If we don't do that, we run the risk of incomplete combustion, and of course there's a liability and a responsibility to the consumer and to ourselves to install an appliance correctly. So on this slide there are some sources. Please pause it if you want and go away and look these up. These are just some articles or references that talk about the importance of correct operating pressures at a gas appliance. So what was the outcome of my findings? Well, 62% of boats I tested had low operating pressure. 54% of those boats across all age groups had incorrectly designed gas piping contributing to low pressure. Only 32% of the boats I looked at actually had correct operating pressure, and the over high pressure in the middle of that table there is due to faulty regulators, and the low operating pressure is due to either design, or in a situation where design wasn't the sole issue, it could be identified as being oil in the pipework or another maintenance related issue. And on this slide you can see the effect oil has on a gas pipe. This pipe here is the U shape in a locker. It's suffering with oil separation from the LPG, which is as a result blocking the gas flow. And it follows that where you've got an incorrectly designed pipe and oil blocking it, you've got other things working as well as the design error to restrict that flow of gas to the appliance. So looking at why these low pressures aren't being reported or found, this can be attributed to a number of things such as data errors, poor guidance materials, a lack of competence, the lack of a commissioning process, unclear responsibility, is it the designer, the installer, the boat builder, and training centre knowledge. Thinking back to our method Venn diagram, we're beginning to lose a few of those crucial factors around the edge here. So there is an error in PD 54823 2016, which is in effect rubber stamping undersized piping by permitting low pressure at an appliance. Table H2 makes a statement that 25 millibars is a safe minimum for a 37 millibar appliance, but it does note the appliance performance will be affected. However, when you look at where the information is taken from, the standards relate to a safe minimum for a regulator to operate at, not a gas consuming appliance. This slide then shows you a selection of commonly found appliances on boats with information about their operating pressures taken from instruction manuals, and as you can see, none of them get anywhere near the 25 millibar suggested as being okay in the PD. So thinking back to the need for commissioning then, in ISO 10239 we are limited to an air test only, which means that it's possible for a gas system to be passed to a consumer having never had gas put through it at all. This means it's never been verified by a qualified professional. I've written a paper about that, the address is there if you want to go and view that. So essentially this poor design that we found is being unchecked, and 83% of gas engineers when interviewed believe that new gas systems are just not adequately installed. So to recap then, That's incorrect design data in the training since 2008. There's no commissioning process to verify the design, and the error in the PD is permitting the low pressure to exist. Current commissioning processes mean that qualified gas professionals can be bypassed and the consumer receives the system without full commissioning. Only 3% of gas engineers say they attend new boats to test systems. Yet if we look at the hire industry, we can see that professional working increases safety. Looking at BSS data showed that 10.4% of private boats had a gas leak in 2021, compared to 4.6% of hire boats, and this is despite the intense hire use. So looking then at gas leaks, there is some evidence of underreporting. BSS data shows 10% of boats with gas have a leak versus 22% of boats that I examine. There are varied possibilities which include reporting diligence, individual underperformance, training and equipment variance, and overall experience. And if we look at this table, we can see the BSS data at 10%, mine at 22%, and a colleague's at 32% of boats he examined having a leak. Looking at this slide, we can see the incidences of reporting is roughly double for both private and hire, suggesting underreporting across both sectors. Looking at this slide, this focuses on incidences of gas leaks year by year. The blue line shows you an increase in incidences in private boat gas leaks as reported to the BSS, and the yellow line shows the hire industry staying pretty consistent, although there's a dip there in 2020, which itself is interesting because it reflects the lower usage of hire boats during the COVID pandemics and various lockdowns. This slide shows again the increase in gas leak incidents as reported to the BSS on private boats and the rise overall. It's possible that the more intense use of a domicile boat coupled with the non-competent working could be contributing to this. Looking then at where leaks happen, the data from the BSS shows a correlation between a piping and a joint fault and a leak, as opposed to another element such as a hose. So looking at the charts there, the incidents of gas leaks are tied pretty closely to reports of jointing and piping faults, but there seems to be no correlation at all to hose faults. This slide is showing some differences between hire and private boats. We can see that there's definitely a greater number of piping and jointing faults in the private sector, much more incident of hose failure, much more incident regarding flue fail points. Appliance burner faults are equally reported, suggesting that higher usage in hire is affecting operation of appliances. And locker faults were found to be the same as well. I wanted to try and work out what causes these gas leaks, and gas engineers tell me it's because of non-competent working, physical damage, or badly made joints. And badly made joints and non-competent working are probably one and the same thing really, and physical damage is the obvious intense use of a boat. The more it's used, the more likely it is to leak. So I tried to work out, are these leaks that are on the increase, are they serious and are they presenting us with a problem? Well, it seems at the moment that incidents of explosions seem to be low, with the BSS receiving an average of 2.7 reports of a major gas incident a year. The 80% of registered gas engineers agreed that low incidence of gas explosion can be attributed to a number of factors, including low volume of leakage, consumer behaviour such as switching off unattended systems when they're not there or going away for the weekend, dispersal due to ventilation, and as such the lower explosive limit is not reached due to dilution or mixing. However, these key factors such as consumer behaviour could become less common when a boat is used more intensely because systems are left on all day, they're not away from the boat, and other factors related to living aboard. So thinking on ventilation in terms of the immediate requirement for people to breathe and appliances to operate, and the long-term requirement for air quality, 14% of all boats were found to have lower than recommended ventilation. But this rises to 19% against boats with gas systems, and it's important to consider it against boats with gas systems because it's highly likely those without a gas system
will have enough ventilation without any need to measure or assess. So the likelihood is the BSS are receiving advisory fails at 891 against boats with gas as opposed to boats without gas, so we need to remove them from the number in order to see how big a problem we have. So continuing to think about the long-term safety of our boat occupants, essentially consumer maintenance knowledge is poor. 80% didn't know when hoses and regulators should be replaced. 20% gave an answer that was wrong.
91% of consumers do not know the service intervals of appliances. 75% do not complete appliance servicing at all. And if we look at this chart here, there's our UK boat owner on the left at 25% uptake in appliance servicing versus 3 examples from the domestic world, including on the furthest right there one reflecting the current cost of living crisis, showing even then a 66% uptake in homeowner servicing.
In terms of reasons for lack of maintenance amongst consumers, I assumed it would largely be cost, or cost would be a common factor. But if we look at the chart there, the common factors were they are working fine, they thought the BSS were adequate, we can let the new appliances or boats off the hook there, but they didn't know they needed inspecting, and there are 3 assumptions there. So they didn't know, they thought the BSS was adequate, and it's working fine, so why service it? Clear message here from gas engineers then. 96% of them agreed that there's not enough consumer information available about gas safety. Thinking about the long-term safety of a gas system and the long-term health of our consumers, 90% of gas engineers do not know what chronic carbon monoxide poisoning is, and all of them are seriously interested in finding out more and how safe appliance operation can reduce the risk to a consumer. When asked about it, 27% could not name a cause, but the majority could. They could, even though they hadn't heard of what it was, once it was explained to them, they knew where it was coming from. And again, this slide just shows us the lack of understanding out there amongst engineers, again derived from errors in the training. When asked about if they could fit an open fluid water heater on a new boat, 70% of gas engineers said they can't do it, and they believe that's because they can only fit room-sealed appliances. And of course this has its root in an error in a standard as well, which has been repeated in the training materials, and it just goes to show that once that information's out there and is taught in a training centre, it's really hard to reverse it, and it does end up being perpetuated across the board. Looking then at carbon monoxide from a consumer viewpoint, awareness of acute carbon monoxide poisoning is extremely good, with 84% naming 2 symptoms and only 4% unable to describe any effects at all. And this is largely due to widespread publicity of acute carbon monoxide poisoning in society in general, but also that the BSS has mandated CO alarms since 2019, meaning the boater has had a direct relationship with the scheme that requires them to be aware of it. However, chronic carbon monoxide poisoning awareness was also poor, with 73% of consumers having not heard of it. And again, once engaged in conversation and talked to about appliance maintenance and the reasons why it's important, all of them wanted to learn more, and there's a real interest in this out there. Conclusions then. Incorrect data has caused poor gas system design across the marine industry. Design is not being tested before reaching the consumer due to a lack of a required commissioning process. Professional working reduces incidences of gas leaks. Maintenance uptake amongst boaters is generally poor, and as the usage of boats continues to change, greater numbers of incidents are probable. The gas safety frameworks in place for what was primarily a leisure industry 40 years ago are largely unchanged and require revision to meet the requirements of the modern liveaboard population. And changes are required in the gas industry to address the above points, and further work is required across the sector. So it's important to note the research limitations I encountered. The main one was the lack of available research in the inland waterways, with there being virtually no specific academic work in the sector. There's no significant data available from other leisure sectors. The liveaboard sector of the waterways is an unknown size, making this difficult to quantify. The reporting accuracy of BSS data is also unknown. The impact of COVID-19 is not yet known, what this has done to the sector in terms of influx of new people with different lifestyles. and the lack of willingness to take part from various organisations due to staff change or lack of knowledge was widespread. In terms of further work, we need to improve the harmonisation of our standards to ensure we link design, commissioning and maintenance. We've got to increase our safety delivery and look at adjustments to meet the demographic change we face. We need to introduce mandatory commissioning to test that design and safeguard the consumer. Could BSS examiners become gas professionals, increasing that professional presence? We need to reduce gas leaks on private boats, and to do that we need to tackle non-competent working. We need to review the risk register, react to and improve data reporting accuracy. Engineer training, we've got to have right materials and we've got to ensure the delivery of that is correct. And we need to research chronic carbon monoxide exposure and exposure to other products of combustion within an accommodation space, and research the risks the boaters are exposed to. In terms of further work, it's important to note LPG is probably not going away. We've got bio LPG already out there. It's not available in bottles yet for boats, but it won't be far away. On this page then, some early outputs. It's important to note that these are changing regularly because things are developing and I'm getting results. First off, I got the MSc. I've had widespread interest from colleagues, consumers and stakeholders across the sector about all of this. Training materials have been amended. We've got a HSE inspector investigating some errors and impacts, and the aim is an industry-wide technical bulletin. Gas Safe Register have now published some amended incorrect data. BSS engagement has been good. We've had meetings with the technical team, presentation at the technical committee. IIMS included it in a training day and hope to use some of the findings and processes in future work. And at IMRS, we're going to talk about it at the Small Ships Group meeting at SeaWork. And a commissioning paper has been published, and I've got interest from CEN and ISO, and contact has been made with BSI. So thank you. It's over to you. If you'd like to get in touch, my email address info@smallcraftservices.com. Please do.